In this video, we'll be looking at how to find the coordinates on a curve if you're given the gradient at that point. So in this case, we're given the gradient or the slope, it's 4. So we know that at a certain point or perhaps points, the slope of this curve is 4, and we want to find out where that is. So the first thing that I always like to do, and it's not a must, but it's good to be able to visualize, I like to draw my graph on the calculator so I can take a look at what it looks like. So now I have an idea of where the slope is positive. I can see that the slope is positive over here and the slope is positive over here, which means that perhaps the point with coordinates with a slope of 4 is somewhere up here or maybe down here or both. All right, so in order to figure out the slope of the curve anywhere on the curve, we need to differentiate, because remember the derivative is the same as an expression for the gradient. So let's go ahead and differentiate, and I'm going to do that as if you already know how to differentiate. And if you don't, you might want to check back a previous video. So we're multiplying 3 by 3. We get 9x, and subtracting 1 from the exponent, we get squared, minus differentiating the 5x, we get 5, and differentiating the 2, we get 0. So we know that the derivative, dy over dx, is 9x squared minus 5. However, we also know that the gradient at this particular point is 4, points I should say, is 4. So remember that the gradient and the slope and dy over dx and the derivative, these are all the same things. So in fact, that means that 4, since the derivative and the gradient is 4, is equal to 9x squared minus 5. We have to make our derivative equal to that given slope. Now we can go ahead and solve. And as you can see, there is a square here, which means that this is a quadratic equation. So when solving a quadratic equation, a great first step is to make our equation equal to 0. So I'm going to subtract 4 from both sides, and we get here that 0 is equal to 9x squared minus 9. All right, now this looks like we have a couple of options here. We could take out a GCF because 9 can go into both, or we can look at the difference of two squares. I think it's always a good idea to take out the GCF. In this case, it doesn't matter that much. So we get 9x squared minus 1 is equal to 0. And lo and behold, we still have the difference of two squares here. We have a perfect square here, a perfect square here, and they're being subtracted, so we can factor this. So I'm going to take this and pull this up here. This factors to give you that 0 is equal to 9 times x plus 1 times x minus 1. All right, which means that when you solve this quadratic equation, you get that x is equal to -1 and +1. All right, let's take a look back at our calculator and see the coordinates at which x is 1 and -1. All right, somewhere maybe around here. And it's kind of hard to do on this tiny thing. And maybe around here. All right, so we're looking at an estimate of maybe 1, 3, and maybe -1, 1, or it's hard to see. So at this point, what you would want to do is plug back into the original y equals equation to figure out your y coordinates. All right, so I'm going to turn the page. Okay, so far from the work we've done, we know that when the gradient is 4, we know that our x values or x coordinates are -1 and 1. And we kind of looked at the graph to see where that could possibly be, but that's not, enough to estimate where the y coordinate is. We actually have to plug into the y equals formula. So our original y equals equation said that y is 3x to the third minus 5x plus 2. So when x is 1, y is 3 times 1 cubed minus 5 times 1 plus 2. So when you go ahead and work that all out, you get that y is equal to 0. So the first set of coordinate points that have a tangent with a slope of 4 is 1 because that's the x value and it's matching y value 0. So that wasn't drawn that great. That should have been a little bit lower, maybe down here. So that tangent at 1, 0 will have a slope of 4. All right, and then there is one more because there is one more x value. So as you can see here, x can also be -1. So we can go ahead and plug -1 into our y equals equation to figure out what y is equal to. So again, I'm just going to rewrite that original equation, which is y equals 3x to the third minus 5x plus 2, and this time we're going to see what y is when x is equal to -1. So -1 to the third minus 5 times -1 plus 2. And when you plug that all in, you get that y is equal to 4. So the second set of coordinates with a slope of 4 is -1, 4. It's probably worth also mentioning the fact that in order to figure out that y coordinate, we didn't have to go in and plug in to our equation, our original equation, and do all the arithmetic here. We could have, since we already had that original equation in the calculator, we could have used value to figure out what y is. And if you're not sure how, it's in one of my other videos. But if you don't, and you know, this is perfectly reliable, just make sure you are very careful, especially when it comes to dealing with negative numbers. I just have one more point to make, and then we are done. Okay, so here's the point that I wanted to highlight in the end of this video. This is the exact same question type as the question that we just worked on. So yes, you may be saying, well, it's not giving us a slope here, and in the question before it did give us a slope. But in fact, it is giving us a slope. It is very important to remember that at maximum and minimum points, the slope is always 0. So in this case, here is a local maximum, and at that point the slope is 0. Here's a local minimum, and at that point the slope is 0. So in this case, we would have to differentiate like we did before, and I'll just do it very quickly here. And then in order to figure out the x coordinate, we'd have to make our derivative equal to 0. And then, just like we did before, we would have to solve, factor and solve. So 3x plus 2, I'm doing it very quickly, just want to bring this point out here. And therefore, our x coordinates would be -2/3 and +2/3. And then we'd go ahead, plug back into the original equation to figure out the y coordinates. So again, the point I needed to make here is max and min points are given slopes. It's just very subtly given and not explicitly so. So you have to know that whenever you see this, they're telling you that the slope of the curve at that point is 0.